Okay, you got that?
Yeah, thank you.
All right, let's move on. Example 4 is not that important, so I'll skip that one. This stuff is important though. This is this I'm going to slow down on. All right, so uniform motion. What uniform motion means is that you set the cruise control in your car and you go 60 miles an hour for 4 hours or 70 miles an hour for 3 hours. You keep your speed constant for some given amount of time. And so if you were to do 60 miles per hour and you did that for say 3 hours, you know that you go 60 miles every hour. So that's 120 miles for 2 hours and 180 miles for 3 hours. So it says that the distance that we travel would be 180 miles. And so the rate is the speed, miles per hour, and then the time is the 3 hours. And so we say distance equals rate times time. So when solving these uniform motion problems, we're going to use this table to set up our information. And at the top of the table is always your formula, distance equals rate times time. And we'll have some kind of first part and second part, and we'll fill in this box, these two boxes, and we'll use the formula to multiply these two together to get the distances. Okay, so let's see how this works. I'm going to try to copy paste this table here real fast so we have it to fill in. All right, with all the word problems, most of the word problems I do in this class, tables help us organize our thoughts. Okay, so you read through the problem and it says two bikers, Jose and Luis, start at the same point at the same time and travel in opposite directions. Jose's average speed is 5 miles per hour, more than, that's a typo. That of Luis. And after 3 hours, the bikers are 63 miles apart. Find the average speed of each biker. Okay, so the two objects traveling are Jose and Luis, and we're going to put those right where we have object 1 and object 2. Object 1 is Jose. And object 2 is Luis. So they start at the same point at the same time and travel in opposite directions. Jose's average speed is 5 more than whatever Luis's speed is. So I'll call Luis's speed L, and then Jose's 5 more than that. And then it says after 3 hours, which means the time that they travel is 3 hours each. They end up being 63 miles apart. So the picture that you see is they start at the same point and travel in opposite directions. When they travel for 3 hours, since Jose is traveling faster than Luis, he gets a little further than Luis does. Well, in fact, it's 15 miles further than Luis because he was going 5 miles an hour faster. Now I need to use this 63 miles. But remember, I said let's fill in the 4 boxes and use the formula that distance is rate times time. So L plus 5 times 3 is the distance Jose travels, and 3 times L is the distance that Luis travels. Now, remember, these are distances. And when they traveled one went one way and the other went the other way, but after 3 hours, the distances together add up to 63 miles apart. So Jose's distance plus Luis's distance is 63 miles. So we take these two pieces and we add them up and set it equal to 63 miles apart. Luis's distance is 3L. Jose's is 3 times L plus 5. And that represents their distances being 63 miles apart. So then we just start solving this. 3L plus 3L plus 15 equals 63. The left side gives us 6L. And subtracting 15 from both sides is 48. So from that equation, when you divide by 6, you see that L is equal to 8. So that's the speed of Luis. Luis is 8 miles an hour. And then remember, Jose was traveling 5 miles an hour faster than that. That's 8 plus 5, which is 13 miles an hour. So the way you check this is to say, well, if they do this for 3 hours each, then Luis is doing 8 miles an hour, which for 3 hours would be 24. Jose's 13 miles an hour, which for 3 hours would be 39 miles. And when you add those up, there's the total of 63 miles apart after 3 hours. Okay, so that's one type of uniform motion problem. I point out again that they told us that after they traveled for 3 hours, they ended up being 63 miles apart. The next one, 6, says Tanya, a long distance runner, runs at an average speed of 8 miles per hour. Two hours after Tanya leaves the house, you leave in your car and follow the same route. If your average speed is 40 miles per hour faster than Tanya's, how long will it be before you catch up to Tanya? Tanya and you. Tanya's a long distance runner and she runs at an average speed of 8 miles per hour. When you see miles per hour, that's a rate. That's 8 miles per hour. 2 hours after Tanya leaves the house, you leave and follow the same route, and your average speed is 40 miles an hour. So the picture looks something like this. They're at home, and Tanya takes off and runs, but she runs for 2 hours while you sit at home and don't do anything. You don't go after her. So that means she's going to get 16 miles away. And then you get in your car and start driving at 40 miles per hour to try to catch her. But she continues to run at 8 miles an hour. So you're going to be making ground. And at some point, you're going to catch up to her. So it's the times that are unknown this time. How long will it be before you catch up to Tanya? If I want to know how long it takes you to catch up to Tanya, I'll let your time that you travel equal to T. And then that will tell us when we solve for T how long it took you to catch her. But see, Tanya traveled for 2 hours while you sat at home. So what that means is that Tanya was traveling for 2 whole hours more than what you traveled. And so all of these uniform motion problems go the same way. Once your 4 boxes are filled in, we write the distances. 8 times t plus 2 and 40 times t. Now, the last problem, we said they got 63 miles apart, so we added them up and set it equal to 63. This time, you are trying to catch her. And at the moment that you catch her, your distances will be the same. Same means equal. So we'll have 8 times t plus 2 has to equal 40 times t. So now you've seen the two scenarios that can happen with uniform motion problems. You either add them up and set it equal to some number, or you just set the two expressions equal to each other if it's the following the same route or catching up with each other. So we solve that by distributing the 8 across. And then getting the t's all on one side, we subtract 8t from both sides. 40 minus 8 is 32. Dividing by 32, we get t equals 16 divided by 32. And that's 1/2. So it takes 1/2 an hour to catch up to Tanya. So just a half an hour. But it also asks how far will we be from home once I catch up to her? And there's two ways to find this. How far is the distance? So it's either take 8 times t plus 2 or 40 times t. T is 1/2, so 40t will be 40 times 1/2. Or if t plus 2 gets put in there, 8 times t plus 2, then t is 1/2, so 1/2 plus 2 is 2.5, which we write that as 5/2, and that's 8 times 5/2, which is 20 miles. So it takes a half an hour to catch up to Tanya, and we'll be 20 miles from home. Okay, so let's take a bit of practice, and the table will help you greatly if you always make the table. You fill in your 4 boxes, multiply across to get your distances, and then you have to write the equation with those distances. Okay, so that's all I want to cover on those. 2.8 will be a little bit easier, or a lot easier, I should say. And 2.8 is about solving the inequalities in one variable. So what you should have gathered in the equations in one variable is that anytime we solve something like 2x plus 3 is equal to 7, we always subtracted 3 from both sides first, and 7 minus 3 is 4, and then divided by 2, and we get x equals 2. All right. You remember that? 2x plus 3 equals 7, x equals 2.
Yeah.
All right. So those are what we call linear equations because the equal sign. All right. Do you remember about these symbols, the less thans, greater thans?
Mm, yeah, kind of.
Kind of. Okay. So this symbol means that 4 is to the left of 19 on the number line. And so we would write 4 is less than 19.
Okay.
On the other side of the number line, you have negative 11 and then negative 24 in that way. And since negative 11 is to the right of negative 24, we say it's bigger than negative 24. That's what you need to know about those symbols. But remember the or equal to's underneath those, just change one minor thing. It's less than or equal to when we write those. 3 is less than or equal to 4. Since it's less than 4, that's a true statement. 3 is less than or equal to 3. Because 3 equals 3, it's a true statement. When 3 is greater than or equal to 4, if we ask, is 3 greater than or equal to 4, 3 is not greater than 4. That's false. And 3 is not equal to 4, so that's false. With that symbol, it allows the two numbers to be the same. And so let's look at what that means. X greater than 4 means it's all the numbers to the right of 4, but you don't get to include the 4. If it's X is greater than or equal to 4, then it's all the numbers to the right of 4, but we get to include 4. It's kind of like saying something like, if all the people 21 and over get to drink alcoholic beverages, 21 is included. But if we say all the people, say X is greater than equal to 21, you get to drink alcohol, but we could say that all the people greater than 20 get to drink the alcoholic beverages, then 21 and above, but not including 20. Now, what you have to get used to is with the use of a parenthesis to denote the greater thans, meaning not included. And the bracket is what we include for, is what we use for included. It's just notation. So when we see X is less than 3, we're going to go to 3 and use a parenthesis and everything to the left. If we see X is greater than or equal to 3, then we're going to come and we're going to use a bracket on 3 and everything to the right. All right. So example 1. When we see this compound inequality, that means two things. It means X is less than or equal to 0. And this statement, you have to be able to read it backward. Because it opens up on the X, I'm going to make sure to keep it open on the X is greater than negative 2. So it's everything greater than negative 2 and less than or equal to 0. That's the graph of that interval. Again, notice the parenthesis for the greater than and the less than or equal to gets a bracket. Negative 3 is less than X, or X is greater than negative 3. So it's everything to the right of negative 3, but it's a parenthesis on the negative 3 to show that we don't include it. And then letter C, what you should have gathered from A is that that's the left-hand point, the negative 2, and that's the right-hand point, 0. So this left-hand point is negative 1.5, and the right-hand is 2.7. Not included is parenthesis. Included is a bracket. Okay, do you follow that?
I think so.
Okay. We will now look at some examples. When you solve an inequality, you solve it just like you were solving equations. Get all your x's on the left and all your numbers on the right, or vice versa. It doesn't really matter. We have to get all of our variables on one side. So I add 3x to both sides. Negative 2x plus 3x is 5x. And then we get all the numbers to the other side by subtracting 3, and that gives me 7 minus 3 is 4. Okay, so I added 3x to negative 2x, which gives me x. Okay, is that clear?
Oh, so it's not 5?
No, I made a little mistake there, sorry.
Okay, I
when
was
I,
gonna.
yeah, when I add 3x to both sides, that canceled that, and then positive 3 minus 2 is a 1. Is that clear?
Yeah.
Okay. And so that says x is less than 4, so we go to 4, everything to the left, and we use a parenthesis on that. Now, there's a little bit more to this, which is the set builder notation and interval notation. So I go back and I show you what interval notation means or is. Interval notation from a graph, you always put the left number on the left side of the comma and the right number, which in this case, since it goes all the way to the right, it's infinity. And then you use the same notation, parenthesis there, and infinity always has a parenthesis on it because it's not a real number. You can't include it. So if you look at all the numbers greater than or equal to a, the leftmost number is the a, and it goes all the way to positive infinity, but we're including the a. And so that's where that interval notation comes from. And so then if everything is greater than a, we go from a to infinity. The leftmost number is an a, and the right is an infinity. If it's less than or equal to a, this time the leftmost number is over here at negative infinity and goes all the way to the right number, which is a, and we use a bracket because we're including it. If it goes from negative infinity to a, we always use a parenthesis on infinity and less than a, so we don't include it. And then finally, if it's the entire real number line, it goes from negative infinity all the way over to positive infinity. All right, that's what interval notation looks like. If it's x is greater than negative 3, from the graph, it starts at negative 3 and then goes all the way to positive infinity. If it's one of these guys like negative 2 to 0, we're not including the negative 2, and we're less than or equal to 0, the leftmost number is negative 2, and the right is 0. And if it's from negative 1.5 to 2.7, the leftmost number is negative 1.5, and the right is 2.7. And then we include and not include, so parenthesis and bracket. And so x is less than 4, our interval notation is from negative infinity to 4. All right, the set builder notation is really simple. The set builder notation looks like braces, which is what we call the set of, and it always goes the set of x's such that, and all you do is just insert the inequality there. It's really uneventful, not much going on there. Okay, the one new thing that we need to add to this is when you multiply or divide an inequality by a negative number, you have to flip over the symbol. So if I have something like negative 5x is less than or equal to 20, in order to solve that, we have to divide by negative 5 to get rid of the negative 5. But when you divide by a negative number, you have to flip over the symbol and get x is greater than or equal to negative 4. And now you graph that at negative 4. Greater than or equal to negative 4. And then interval notation, the leftmost number is negative 4 and the right is infinity. We don't include infinity ever. And in this case, we include negative 4. And remember, set builder notation is just the set of x such that insert the inequality in there. Letter B, having that negative 4/3 p, we have to multiply both sides by the reciprocal of negative 4/3, which is 3/4, and negative. So because we multiplied both sides by a negative, we have to flip the symbol greater than to less than. You get p is less than, this 4 cancels this, and we're left with the negatives going 3/5. So 3/5 is a 0.6. We go to 3/5, everything to the left of that, and we use a parenthesis to denote not included. Interval notation is from the left, which is negative infinity, to the right, 3/5. Parenthesis. And then set builder notation is the set of the variables such that p is less than 3/5. Okay, so this section was a lot about how to solve the inequalities, and you treat it just like a linear equation unless you multiply or divide by the negative number. And then it's about the 3 different ways to represent the solution, well, 4 ways really: the inequality, the graph, the interval notation, and the set builder notation. Okay, and so that's all I'm going to cover on that one. And I'm going to get into 3.1 and 3.2, which is the rectangular coordinate system. So it's kind of frustrating at first because you see these what are called ordered pairs right after looking at interval notation. They seem to conflict with each other, but these are something entirely different. This 3.5 says go first to where x equals 3 on the x-axis. over 3. The y equals 5 says to go up 1, 2, 3, 4, 5 to that point right there. So that is the point 3 comma 5. Have you done this before?
I think so.
Yeah. The point -2, -4 says to go over to -2 on the x and go down to -4 on the y. 0, -2 says to stay at the y-axis and go down to -2. So it's really important that you see that if the x is 0, then you're on the y-axis. If the y is 0, then we're on the x-axis. So we go over to -3, 0. And then 3, -7 puts us over here, 1, 2, 3, and down 1, 2, 3, 4, 5, 6, 7, puts us over here in what we call the fourth quadrant. Okay, so that's how you plot those points. And what we'll have is these equations in two variables, y equals -3x plus 5. So that's thought of as a formula that tells you what y is. You always take -3 times the x value and add 5. So if x is -3, then we take -3 times -3, which is 9, plus 5, which is 14. The easiest one to plug in is x equal to 0. -3 times 0 plus 5 is 0 plus 5, which is 5. If you plug in x equal to 1, that's -3 plus 5, which is 2. And then lastly, when we plug in 2, that's -6 plus 5, which is -1. And then what we'll do in section 3.2 is just call all of these ordered pairs, -3, comma 14, 0, comma 5, and so on. And then we'll plot those. The ones that are a little harder to do are when the x and the y are on the same side. The last problem was y equals, and this one is 4x minus 3y equals 12. And so if x is -1, I have 4 times -1 minus 3 times y is 12. These aren't as easy to solve for anymore because each of these has an equation that we have to work with. Add 4, and that's 16. Dividing by -3 gives me -16 thirds. If we set y equal to 2, then this time we'll have 4x minus 3 times 2 equals 12. 4x minus 6, we add 6 to both sides and get 18. And solving that, we have to divide by 4. 18 is not divisible by 4, so we write it as 9 over 2. All right, so that's certainly kind of frustrating or not ideal to get those fractions. And so we'll be developing methods so that we don't have to deal with those in this section. But the easy ones are coming. The easy ones are setting x equal to 0 and y equal to 0. So if I set x equal to 0, watch how this works out. Then you're going to have 4 times 0 minus 3y equals 12. Setting x equal to 0 wipes it away, and you're just left with negative 3y is 12. And you can see that in the original equation by just covering that up. And so what does y equal? If negative 3y is 12.
Oh, negative 4.
Good job. So do that up here for setting y equal to 0. So cover that one up. And that says 4x is 12. What would x be?
3.
Good job. Those are what we call the intercepts of the graph. 3, 0, and 0, negative 4. That is pretty much what we need to make that graph. So we'll talk about that in more detail later. And so if you have something like this problem, practice 3, if I set x equal to 0, then I cover that one up, and that's 18 over negative 5. But if I set y equal to 0, I cover that one up, and that's 18 over 2. So those are always the easy ones to find, the zeros. And then I'll show you techniques so that we don't have to end up getting fractions for some of our points. Those are always a little bit challenging to plot. All right, 3.2. Now what we do is graph these equations by plotting points. And so what we just saw was that if you set x equal to some number, then you can get a y value out of it. And if I set x equal to negative 5, then I'll get 3 times negative 5 minus 2, which is well off my graph paper. Negative 15 minus 2 is negative 17. So let's try negative 1. 3 times negative 1 minus 2 is negative 3 minus 2, which is negative 5. So we need to make these into an ordered pair to plot them. Negative 1, negative 5. 0. Can you tell me what y is if x is 0?
Oh, 2 or negative 2.
Good job. And it's staring at you, huh? Not much to do there. And what about if x is 1?
1.
Did you say 1?
Yeah.
Good. Do you see a pattern here? Negative 5 to negative 2 to 1?
Yeah.
What are they doing?
They're like, they're going like
They're
down.
going up by how many?
1.
Negative 2 to 1 went up 1, 2, 3. So the next one, if I do 2, will be 3 times 2 is 6 minus 2 will be 4. So 1 plus 3 is 4, and then 3 will be a 7. And so we'll just keep putting points by going up 3. And so that's what our line looks like, using a straight edge through all of those points. That's what our line looks like. If it's in this other form, 2x plus 3y equals 12, this is a little harder to work with. Now, a good thing to do is to do the intercepts that I was just talking about. The intercepts of the graph are these spots where it crosses the axes. This point is x equals 3, 0. That's the x-intercept. And this point is 0, negative 2. That's the y-intercept. So notice how the x-intercept is found by setting x equal to 0. And so remember that if I set x equal to 0, I cover that piece up. And that gives me 4. If I set x equal to 0 and get 0, 4, that's where it crosses the y-axis. So this is what we call the y-intercept. If I set y equal to 0, then I get 2x plus 3 times 0 equals 12. That's just 0. Or 2x is 12 gives me 6. And when I plot that, I get 6, 0 there. And that's what we call the x-intercept. I need some more points on this graph, and I don't want to get fractions like I did before. So what I'm going to do with this is solve for y. This is a process that's going to take a little while to get used to, but it's super crucial. This is something you're going to do a lot of in this chapter 7 or chapter 3. So we solve for y. We want to undo this adding 2x to the 3y, so we subtract 2x from both sides. $12 and minus 2x are not like terms, so we just add them, negative 2x plus 12. Now we divide both sides by 3, and we get y is equal to negative 2/3 x plus 12 over 3, which is 4. That's the equation that's easier to figure out what to plug in for x. I don't want to plug in a 1 or a 2. I want to plug in numbers that divide out this 3 in the denominator. So let's plug in x equal to 3. If x equals 3, negative 2/3 times 3 is just negative 2 plus 4, which is 2. So that's 3, 2. See how we're not getting any more fractions there? This was my goal. I'm going to plug in negative 3 as well. The 3's cancel. And I have positive 2 plus 4, which is 6. And if I plug in negative 6, just multiples of 3 there, I'll have negative 2/3 times negative 6 over 1 plus 4. And 3 goes into 6 twice. That's 4 plus 4, which is 8. Hopefully you recognize this pattern that all these points are going left 3 and up 2. Left 3 and up 2. Which means they're going right 3 and down 2. And that's what we call the slope of the line. And that'll be covered in, I believe, 3.3.
So then how do I know what numbers to choose?
Say that louder.
How do I know what numbers to choose?
Good question. See how that denominator is a 3?
Yeah.
You want to choose any number that's divisible by 3. Because if I choose 5, then I'll have negative 2/3 times 5 over 1, which is negative 10/3, plus 4, and that's a fraction.
Okay.
But if I choose 9, then I have negative 2/3 times 9 over 1 plus 4, and 3 goes into 3 once, into 9 3 times. That's negative 6. The denominators are 1, so you have this whole number. You have this integer. You get negative 2. So there's the 9 negative 2 right there. So to answer your question, whatever that denominator is, only use numbers that are divisible by that denominator. Does that make sense?
Yeah.
Okay. Because remember what we were doing a little bit ago. Because I didn't solve for y on this problem and just plug these numbers in, I ended up with fractions. All right, so I need to connect those dots to the line. And there they are. Okay, I'm getting towards the end of this, so I'm just going to tell you one quick piece of information here. When the equations only have one variable in them, like y equals 2 and x equals negative 3, it's either a horizontal line or a vertical line. And you can see this by saying if y has to always be 2, and you plot those points, negative 3, 2, and 0, 2, and 1, 2, and 4, 2, if they're always going to be 2, then all you're going to do is graph a line through all the y equal 2's, which gives you horizontal line. So y equals are horizontal lines, and if x must always be negative 3, go over to negative 3, 0, negative 3, 4, negative 3, negative 8, negative 3, 3. All these spots where x is negative 3, you're going to graph a vertical line. Okay, you kind of just have to memorize that. Now be very careful though, because when you graph, say, y equals a number times x, that's not a horizontal and vertical line. That's a line that goes through 0, 0, 1, 3, 2, 6. That has a slant to it. All right, Taylor, so I'm going to go ahead and quit now. If you have any questions, I'd be happy to answer them.
I have one more question. So what's the exam going to be like in the TLC? Like, is it based off of specific homework questions or based off of this review stuff?
Oh, it's even better than that. It's I'm gonna give you a review. Let's see if I can find it. So it looks something like this. That's the wrong one. Exam 1 review. There it is. So I'm going to give you an entire set of problems to work out, and the exam will have these types of problems on them, but much less.
Is this one printable, or is it something I have to do on like homework?
This is something that you'll print out and work on your own. It's not anything you have to turn in. So I will be posting this in Canvas by this weekend.
Okay, sounds good.
And so there's there'll be a page that says something like exam 1 information off of Canvas. And I'll give you links to the videos where I've worked out all these problems on YouTube.
Okay, thank you.
Have you seen those other videos that I've been posting?
Yeah.
Okay, good. These archives, I put them on YouTube and then post a link to them, but they're not complete. So it's better that you actually just watch the videos.
Yeah,